Hello everybody, my name is Barsha and we are talking about threads and blocks. So we have blocks which are two-dimensional thread array and also grid that is two-dimensional block array. So this is full form. We didn't include three dimensions, but this is enough just for the talking and to see possibilities. So why do we taking the grids or more blocks? Well, we want to distribute our parallel task in more available streaming multiprocessor at times, so we avoid jamming and one streaming multiprocessor to be overwhelmed with the tasks. So there is some limits which how many threads we can put in one block. So we must think about that. And if we want to reduce number of threads per block, we must do some actions, and that's the 4 more blocks which can be executed, and even two-dimensional blocks. So we have case here before the calling the function. We have case of forming the 2D block. So we have indexes for blocks in X and Y dimension, and also in one block we have two dimensions X and Y for the threads inside the block. So one block is 3 times 3. We have index for X and index for epsilon. So that's the main difference between this example and previous examples. We going standard way with includes. This one is for C++ normal, and this one is for CUDA C++ extension, so we can make functions or kernels in device or GPU. We have our standard, let's say not standard, but changeable, little bit changeable kernel function, which we say here just according to name that we are, what are we doing? We are doing turning kernels into multiple threads which are executed in parallel, and for every thread we have indexes for X and Y, and also X and Y threads, so it's a 2D array of threads, and also indexes for blocks of threads where we store our, let's say, set of threads inside of it. We have these variables where we put these built-in variables or indexes, so we can manipulate with them later somehow if we want to do some address arithmetic or something like that. But in this case, this is just poor representation, pure representation of these data, of these indexes, and we want to print these variables X and Y according to what we put here. Threads, we print the IDX and ID epsilon, which are picking up these values from built-in variables from index of to the array of threads. Then we skip or jump into the new row, and then we want to print dimensionality of that block, which consists of threads or array of 2D array of threads, and how many of them we have in X dimension and Y dimension, how many threads, of course, but also we have blocks per grid, and we want to print out the dimensionality and to see how many blocks we have in X direction, so this direction, and how many blocks we have in grid in epsilon diversion, so it means vertically, and we picking up the rows of these blocks. So we have threads inside the blocks and blocks inside the grid, and in everything is 2D here, but let's check this, and we want to see dimension of block and dimension of grid, which is consists of blocks. We have our main function, and we say here execute main program This is just words that we mark the beginning of the program. Then we have or define threads per block. So we have 3 times 3. 3 times 3, we can change, but no, let's not change. 3 times 3, it's 9 threads per block. So 3 in X direction and 3 in Y direction. These threads and also blocks, we have these two in X direction and these two in Y direction. And it's analogous to previous case where we have one block which is two-dimensional array of threads. Now we also have more blocks. It's not one-dimensional, it's two-dimensional. Also, you can see that in calling of the kernel functions when we're turning into threads, we see that we are putting this value blocks per grid here. So we say how many blocks per grid we have here. So it's 2 times 2, it's 4. And we have threads per block where we're saying how many threads we have in one block, which is also two-dimensional problem, not problem, but two-dimensional object. 3 times 3, it's 9. So in total, it will be 4 times 9. Yeah, it will be many. I think 30. How much is 4 times 9? It's 36. Yes, it's plenty for representation, but we will see the results. Also, to remember that we are going instruction by instruction in parallel for each thread and then going to another instruction per thread. We have some CUDA device synchronized, which is probably organized that. So in every other. So once again, in comment to the array of blocks and to the array of threads inside each block. I think everything is clear now. So 2D and 2D problem here. So we can go to the execution. This will be 34 program. Okay. Okay. Let's compile it. We did compiling of this program, then we putting here to execution. It will show probably many things, probably more than 36 of these devils. I cannot pick a number. Okay, what we have here. So for the x-axis, we are going regular and picking up the dimension is 3. We're picking up each. For fixed row, we have for fixed row, which is 0. You don't forget that we're going in epsilon direction when we're picking up the row. We picking the row, and for this row 0, we have 0, 1, 2. We have three, let's say, members of that row, which is on the x. So it's like in this case, index for column is x. So just to be clear. Also, then we're going with ones or row 1. Also picking up 3 elements because it's 3 times 3. And also going for the row 2, also picking up all elements for this row. And then what we got next? The index number for x. Yeah. Block dimension. Maybe I should put here. Okay, this is all good, but let's put also here this one to be more representative. So for each block we have For each block we have uh, yep. For each block we so this is all then going again for next block, for the next block, for the next block, and so on. Okay, we can do it like this, and we then print block dimension here, and we put grid dimension here, cut, let's put some semicolon, yep, and then we do it like this. Okay, let's do the cut, thread x-axis, threads y-axis, epsilon axis. So okay, this one, and yeah. So what is happening here? Can we maybe, yes, we hope that it will write down this, and let's do it for this one. This is also block dimension, which is not purely visible because it's printing down there. These dimensions, yeah, it's mniech. Actually, I don't see that we did thread, yeah, grid dimension, block dimension. I don't want to put block dimension or no. I want to put, where am I? I'm disappearing. I want to put not block dimension, I want to put block IDX. Yes. IDX dot X, and I want to put I'm not sure that this one will function, but block IDX dot epsilon. Okay, and yes. So grid dimension, grid index. Yep. Grid. No, block index. Block index. Block index. Index on x-axis, and we have block index y. Okay, and then we have all these block 1, 2, 3. We're missing here one D, and then we go back, and we can put here block dimension. Yes, block dimension. Dot X, and there, and also a block dim dot X. Okay, we put it here. What are we missing here? Let's save it, and then we will do it also like this to check everything, but this one will be epsilon. We're missing here D. That's nice and easy. We need semicolon here. Nice and easy. Why do I have? Mm, 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 mm. Mm, mm, mm. Okay, this one, and I hope everything is fine now or not. File save. What I am missing here, expected expression. Ah, yeah, but yeah. Ah, I switched the. Okay, okay. This one is going here, and this one is going here. Now it's better. And also, let's do it. Yeah, it seems that I'm dyslexic with this. And this one is going here. Yep, everything's fine here. Let's save it and do some execution. So we are picking thread idx, thread idx.x, thread idx.epsilon, block idx.x, block idx.epsilon in first row, so it can be more to be more oriented. And then I'm picking up the dimensions here of the block, and then picking up the grid dimensions, which consists of the block, and this one should be twos, thread index, blah blah blah, grid dimension. Do we have the grid dimension? Yes, we have grid dimension written down. Grid dimension epsilon with grid dimension x, so everything is clear. But for the multiple threads, multiple writing, so nothing unknown. And then let's go to compiling again. Oopsies. Then let's again do the compiling. What is happening? The format string requires additional requirements, arguments. What did I do wrong? Okay. Let's try like this. Warning number. Warnings can be. The format starting requires line 11. Okay, this one should be this one. Yeah, I don't have argument here. Let's erase this body and then go to save. And then a little bit of troubleshooting is always good for the learning. And then go to this. Yeah. So we find the mistakes. It's always good to find your own mistake before anybody else find your mistake. So let's do it again. Execution of the program. Okay, we have the epsilon dimension here, x dimension 2 as we expected. So this is this. And writing down the trees for x and epsilon. Let's put some x here and epsilon here. Save it a little bit so we can make different to see where it starts and so on. So doing again, save. Let's do the execution again, or compiling and execution. Okay, let's go further. Execute. So what have we got here? Okay, grids x and y. X and y is written here. We have epsilon here. As you can see, this is for this dimension, written 18 times because we have 3 times 3 9 blocks, or 3 times 3 9 blocks times 4. Actually, it's 36. Sorry. It's x dimension. For the block, this is this. So this corresponds this. and then we have writing down of these. Okay, let's check where we are. Uh, 0, 0 for the threads and x 0 1, and this is 9 times for one block. And then we have 0 x index 0 1. Then we have 0 0. It's a little bit strange. It's the last one, and the 1 1 indexes are in the middle. Yeah, it's strange because it's counting blocks from the. It's strangely, but I'm not sure. But yes, first block, second block 0, first block 0 1, second block 1 0, third block 1 1, and 0 0, last block with 9 threads. And these numbers are given here, so I hope everything is understandable and visible. So that's it. We finally make 2 dimension of one block and multiple blocks spread into 2 dimensions in grid. So we see how it's going. The total number of threads is actually number of blocks times total number of threads in x and y dimension, of course, and then we see how it's going, how indexes are going. These are going normal, like 0 0. We are going through the columns, but these one block indexes are a little bit strange. How they starting and how to choose first index for block. It's a little bit counterintuitive. And it seems that it's counting down somehow, but okay. Anyway, 36. Then we have writing down grid dimension on X and then on epsilon, this one. So everything is clear here. And I hope that we go very well and get familiar with how to use 2 dimension threads and blocks and grids, and how to use these indexes, and how to make multiple threads of our out of our kernel function to make good and fast executable threads which are doing our task very fast and very well in short time. So for the indexes we will have one more example, and then with more little bit visuals, and then we are continuing with matrix multiplication one way or another using 2D blocks and grids. So up till then, see you and bye bye.